Hello, everybody. Welcome to Compute 353, Computational Data Science. I'm Greg Baker. I'm the instructor, in case you didn't know. Welcome. So, as you can tell, I guess, we're doing this course with lectures delivered by video. Come back to some of that. There is a course webpage in Courses. Let's imagine, have probably emailed you with this link by the time you see this. I'm, of course, not doing this live. This is pre-recorded a little bit, at least. Whoever you are, however you got here, however fraught that path was, welcome. So the reason I'm sort of doing this video thing here is it's really like what worked best. I taught this course across, before 2020 and through the pandemic. And I think what I realized was this sort of medium for the lectures for this course works well. Other courses I teach, I do in person. This one, I just vibe with the video lectures. Trying to do office hours by Zoom, that sucked. That's way better in person. And tests, online tests, suck. You know why. So, as you're seeing this, this is lecture. I'm here, I'm either down in this little box or I am here. This is pre-recorded, but again, for you, it is summer 2026. This is bespoke to you. I have thought about, like, what if I just recorded these lectures and then I could just play them every semester? Wouldn't that be a lot easier? And it feels wrong somehow. It just doesn't feel like me. It would be better. Like, the video quality could be better. I could edit them. I'm not editing this, but I think it's worse. So you're getting bespoke lectures for you. I'm going to deliver them as lectures, which I also know is the wrong thing to do. If I looked in the, how do you teach good online handbook, it would say to not do this. It would say to shorter videos that are, no, these are lectures. Lectures are 50 minutes long. That's what we're doing. If you're watching this in the premiere, what I would think of as live, in the chat, I've probably said hi already, but have a look at the live chat during the premiere. I will be there. I'll be happy to answer questions. Give me a second. Like, if I kind of look away from the screen, it's not super interesting to watch myself give a lecture, but I will be there. And yeah, happy to answer questions. Of course, I can't pause the video because the video was recorded a week ago. After a YouTube video premieres, it's just a regular YouTube video. So if you want, but I'm going to encourage you to come for the premiere. I like the synchronous thing. I think you should stay up to date, etc. Grades in the course, wait, where am I? Like this. So there will be a small exercise due every Friday, except this Friday, adding up there, 3 quizzes I'll come back to, and a final project. If you hand things in late, they are late. So these weekly exercises are like, me tricking you into learning is frankly what's going on there. We have talked about stuff, that week, the week before, sort of time range, as long as I stay up to date on everything and the lectures go as expected. And it's one thing to, of course, watch a lecture and see me say, oh, look, you can do this and this will be the result. It's another thing to actually do it yourself, as you know. I would hope by this point in your career. They're necessarily short, right? If I'm giving it to you every week, I'm trying to be respectful of your time. I've tried to get something real in there. Of course, it's all fake. I don't need 150 or however many of you there are. I don't need these things. They're all fake. All the assignments are fake. I can write this code myself. You need to do it so you learn something. Well, again, this sort of relatively structured core of the course with these lectures and exercises that are quite tightly tied to each other is fine. It's certainly a lot more out there. So the project, which of course comes towards the end of the semester, is your chance to sort of explore a little bit, to maybe maybe you want some other technique. Maybe there's something you think, I want the job there and they want this, so I want that on my resume, the technology or the data science technique or whatever it is. Okay, choose a project with that. That's fine by me. Or you're just really into this topic, choose your project that way. I will, in fact, have posted some project topic ideas. And I guess, by the way, I should have said this, the lecture notes that are here that, again, I've probably sent you a link to or whatever, literally this is what I'm using to give the lecture. There's no hidden anythings here. But on the course homepage, I realize I am not logged in on my lecture giving account. Just a second. Okay, my apologies. I log into a different account on this computer when I'm doing the lectures, just so my email's not popping up and whatever. But of course, that leads to inevitable synchronization problems. Again, course webpage, it will be released by the time you see this video. The exercises are here. Exercise 1 is up now, although it's not due for whatever this is, 10 days or something after the premiere of this video at least. But what I wanted to talk about was the project. The project is very open-ended, like as open-ended as I can make it. What I really want out of the project is you do a data science thing. I have a bunch of project ideas here that are not full projects, or they're not full project ideas. There's still a lot to be sorted out. And that's on purpose, right? I don't want to give you a prepackaged project and say, oh, here's a project you can do, exactly follow these steps. That's not the point. These are half ideas that are kind of weird and incomplete, and that's the point. Right. I'll come back to those due dates at the end of the semester. And yeah, I'm happy to, of course, discuss project ideas with you as they happen. You don't need to worry about the project now. It's a sort of last third of the semester kind of thing. The project is individual. I have done group projects in the past in this course. I think the individual project worked actually way better. The one thing I thought I was doing was getting rid of the group freeloaders problem. You either know that or have been that, and either way, well, if you're happy about not having freeloaders in your group, hey, cool. If you're sad you can't freeload in a group, drop my course. But what happened when I switched to the individual project was the topics got more interesting because, of course, the group choosing a topic idea, things kind of get homogenized and get a little less interesting. Individuals can choose whatever crazy idea they want, and it's actually been more fun, for me at least. So in the project, of course, you're going to use some techniques from the course. You don't have to use all of them. Otherwise, what sense would that make? There may be other techniques you want to use. That's fine. You're going to write a report that is the primary output, really. One caution that I get, like I see students do this in the project. It's like, I use 17 things from the course in the project, therefore I'll get a good mark, right? No, that's not. What you want to do for the project is do some cool data science, and just like applying a technique that doesn't make sense just so you have one more technique isn't a good project. 3 quizzes, as I mentioned, these are in person, on paper, closed book. They are normal tests. The quiz 1 and 2, well, those are going to be pretty fixed. They're on the Fridays, in person in the Friday lecture slot. The 3rd quiz I have scheduled, like I've just said, I would like a final exam, please, and they will schedule it whenever they schedule it. For me, this is like equally good 3rd quiz. It's not a final exam, really, but it's a really convenient way to schedule it, I hope. This also means I don't know when it is as of right now. So the last weekly exercise in the project that are also due around there, like if we have a really early quiz, maybe I'll slide the project after it. If it's later, I'll do it before. Like, I promise to be reasonable, but the due dates of exercise 12 in the project might shuffle, depending on what we learn. So I've already introduced myself. Hello. I will have some office hours. I will do my office hours in the computer lab. I think that room is right. I will have to check. I have an email in my inbox that says, yes, we booked you the room, don't worry. And I don't remember which room. But anyway, I've moved my office hours into Cecil for the last few years. I like it. Many of you are already there, and that's fun. The TAs exist. I haven't actually met with them yet. I'm pretty sure the contracts are finalized as I record this, but we'll get there. If you want help from us, there's a discussion forum. Like, come and talk to me in my office hours or in the Friday session that I'll talk about in a little bit. Go to the discussion forum and ask things there, preferably public, right? If you ask a question, you can ask a private question there. But of course, I look at that and I think, well, am I going to type like some long, beautiful, carefully researched answer where only one person is going to read it? Honestly, probably not. If you ask a question that's relevant to the whole class, then you're going to get a better answer if it's public. It's just the way my time works. Again, if you've asked a public question, but I'm looking at like, geez, I'd really like to update exercise 8, I'm going to do that before I answer a question for just one person. And if you email me, good luck. Yeah, anything's possible. I might answer your email promptly. It's unlikely. So lectures, Tuesday lectures, which is what we're experiencing right now, will be experienced like this. And again, I'll be in the live chat. I continue to imagine I'm there and I've said hello. The Friday lectures are not lectures, mostly. What's going to happen on Fridays is the TAs and I are going to go to Cecil, and we will be there with no agenda. There's no like lesson being taught or whatever. Of course, what there is a is an exercise due. So realistically, the Friday sessions have become like advanced workshop office hour-y things. In Cecil, that has worked well. It's also part of the reason, by the way, I like doing the video lectures. It lets me kind of, I can be relatively dense in my usage of the 2 hours I do get, which again are happening on Tuesdays. There's no textbook for the course, both in an administrative and content sense. If there was going to be a textbook for the course, it's the Jake Vander Plas's Python Data Science Handbook, which you can find. You can find in the SFU library. You can also just get the thing as a bunch of Jupyter notebooks and GitHub. There's this like promise of him doing a new edition that he seems to have started 3 years ago and then abandoned, which makes me sad. It probably could use an update. Python for data analysis. This is by Wes McKinney, who is the creator of Pandas, with a tool we're going to use mostly for Python data manipulation. So if he doesn't know how to do this, presumably nobody does. Data science from scratch. This is Joel Gress. Yeah. I like this book just in my heart. I don't know how practical it is for this course. What they mean by from scratch is without a whole bunch of libraries doing everything for you. So it's like, oh, if we want to do like k-nearest neighbors regress or whatever, well, here's the code that does that. It's on the page. You can type it yourself. I think you can download it somewhere. And it's just really cool. Like it's a nice way to sort of lay everything out. You can do it in formulas, but you can't run a formula. I do like that. The Think Like a Data Scientist, and mostly I will provide links on the lecture slides as I need to. They're web pages after all. By the way, I always get, how do I make a PDF? I don't know how you make a dang PDF. It's a web page. You make PDFs however you want. I don't care. Anyway, so Python is the programming language we are using for the course. If you're not comfortable with Python, you need to be like, let's call that exercise 0. Like if you need a Python tutorial, do a Python tutorial right now. You need that. I will be assuming you can program in Python. And like, here's why. Just like, it is far and away the language for data science, which in some ways seems weird for reasons I'll come back to today, but it's the choice. If you're going to do data stuff, it turns out it will be Python. There's relatively much programming in this course. Some because like I've given you that Friday hour back in my mind, like you have one more hour to work on assignment stuff in this course than if I give them 3 hours of lecture. It's a pretty like we're leaning a lot on a bunch of libraries that will do stuff for us. Pandas, scikit-learn, SciPy, toolkits. That's just how programming works in the modern world. It just is what it is. That means very often like I find myself in a situation of like, I just spent 5 minutes and I wrote 2 lines of code, but I'm done. As opposed to like this sort of, I understand why Compute 225 is the way it is, right? At some point you should see how binary search works, and one way to do that is to make you write it. But then you shouldn't actually do that yourself, right? Like the quicksort built into your language is way better than the quicksort you wrote in 225. You should just call it. Do try to use your brain. Like, yeah, other people know how to parameterize this method to do whatever, but use your brain first, please. And also the reference docs. Like, it's amazing. Like a lot of libraries just have stuff that they do that nobody uses because they're not the common thing that's used. So they're not in the first Stack Overflow answer or known to ChatGPT, but there's an argument you can use for that or whatever. Right. A little more. I think you have a little more time in the exercises every week because I gave it back. For this course, like what I think it means to get credit in this course is you've demonstrated that you know the basic ideas of data science. I don't think that's unreasonable. And there's 2 big ways you're going to demonstrate to me that you know the basic ideas of data science. One is by programming on the weekly exercises and the project. I expect you to do that. The other one is demonstrate that knowledge while I'm watching you, and I know it's you doing that, not your friend, not ChatGPT, not whatever else. I reserve the right to fail you in the course if you don't pass the exams. What I'm not going to do is apply this as like a formula in a spreadsheet. I reserve the right to adjust the meaning of the word pass here. I reserve the right to apply this on a case-by-case basis. And if I do it, it will be because I have looked at your exams and your assignments and decided this person does not understand the basic ideas and therefore should not pass the course. Again, it will be a judgment call on my part, like it or not. This should not be news, right? If you hand stuff into me, you are certifying that that is content that you created. You wrote this code, you wrote this essay, you produced this reading summary, whatever, right? That's just how university works. And if it's news, wow, you're in trouble. That is, when you click submit on an assignment, you are always saying that. For example, if you use an LLM to generate your solution, I am considering that academic dishonesty. And this because I've seen it, students who come in and they say, no, I didn't, I wrote this by myself. And I say, no, this is ChatGPT output. It looks exactly like all the other students that put the thing into ChatGPT, and you are getting a 0 on this. This is academic dishonesty. And then they say, I wrote the code, but I asked ChatGPT to fix it. And of course, didn't notice that it was completely changed into something unrecognizable, or frankly, they were just lying. Just handing in somebody else's work, even if you look at it and you really, really understand it. And you, again, I have students come into my office all the time and say, well, it's not your work. Oh, no, but I went through it very carefully. I understand everything. Nope. Academic dishonesty. This sort of, group, but not group assignment, also academic dishonesty. I might be the university's top academic dishonesty case producer, if any of this looks familiar as the way you do work, the drop deadline has not passed. Drop of the course, frankly. For the tests, these are tests. They're, again, individual closed book on paper. Again, you know what a test is. Again, because we have been seeing it, having any electronics in any way available to you during the quizzes, I will consider academic dishonesty. If your phone is in your pocket, if your phone is on the floor in front of you, if you have smart glasses but you swear they're not being used right now, you have a smart watch but you're totally not using it, it's okay. I am going to treat that as academic dishonesty. You can appeal that if you want. That's it. Again, if you have some kind of hearing aid or whatever, just let me know. We'll talk about it. It's fine. Okay, that aside. And by the way, like, I think I've changed the way I've said this, and it doesn't seem to friggin' matter because the people who do this stuff are not listening right now. For the rest of you who are listening right now, and do your own work and do your own work on the test, you are the reason I'm doing this, right? I want getting this credit or getting a degree from SFU to mean something. I owe that to the students who are doing their own work. That is what you should get. Every student who's using their friggin' phone during a final exam or is having ChatGPT do all their work for them makes your degree worth less. They should fail the course. I want them to fail the course. If by some chance these students are listening right now, drop the course. Okay. Anyway, what are we doing? What the hell is data science? Let's talk about that. The course is called Computational Data Science, frankly, because Stats already had a course called Data Science, and Senate gets angry if you have two courses with the same title. So I put computational on the front of it. Data science, it depends a little bit who you ask. There's some common threads, I think, in the way that people describe what it is. It is interdisciplinary. It does combine sort of different techniques and different ideas. What we care about is answers. Like, we want to come to conclusions, or we want to gain insights from data. Again, combination of a bunch of stuff, bunch of different techniques, in a bunch of different sort of domains. Yep. This is a joke that says a data scientist is someone who knows more statistics than a computer scientist, and a computer scientist is more computer science than a statistician. Yeah, this is probably honestly fair. You know, I'm probably a better statistician than most of the computer scientists. I am a much worse statistician than the statisticians. I bet I can program better than most statisticians. I'm a better computer scientist than most statisticians. I think this is all fair. There's this, I don't know, well-known Venn diagram that I would relabel. I keep thinking maybe I will. I would put programming instead of hacking skills. I would put probably domain knowledge instead of substantive expertise. And stats, sure. I'm not sure that programming plus math and stats equals machine learning, but certainly machine learning belongs in that wedge. And yeah, you know, if you go down the hall and you visit the chemists and the biologists or whatever, a lot of them are here, right? They're actually often quite good statisticians, and of course they know a lot about chemistry and biology and stuff, and they're hanging out here, and they don't know how to program. You are hopefully going to be pulled away from here because it's very easy as a programmer to take some data and just smack it around until it looks like you've achieved an answer, but that answer is actually wrong, or is that not supported by the, you know, right by accident, but not supported by the data. You need a little stats and a little bit of sort of careful analysis to be confident in your conclusions. I am a pretty big tent data scientist. It's anything you do to get answers from data, fine. I'm calling that data science. I'm not, well, even getting the data, I would probably put in the data science category. Just you're doing stuff with data with the goal of having answers fall out, data science. Great. I do have a colleague, again, a colleague who I like very much, who lives over here, who constantly complains to me that, well, how would you have science without data? It's a compound noun, Tony. Anyway, so is data science new? I mean, I guess it depends on the time scale. I've been teaching this course for, what, 7 or 8 years, I suppose now. So that's not so new. But on some longer time scale, yes, it is. It's, you know, we were computer scientists long before data science was a term. In some ways, there's just more demand. Because we build all these things that collect data from, again, the web page or the sensors or whatever. I mean, you know, Google knows that I'm here right now because my phone's beside me and my phone knows where it is in the world. All of this stuff is there, and there are answers to be retrieved from it, whether you think that's ethical or not, whatever. It depends on the data and depends on the question. Sometimes that results in a lot of data, enough data that it's kind of annoying, and I'm going to call that big data, which we will talk about in the course. It's important to not lose sight of the question. It's one thing to get some data and play around with it, but you know, people have the question of like, well, is this working? Or what if we did this? Or is there some better way to do that? Can we identify customers that have some property that, and yeah, these are all important questions. Sometimes these are statistics questions. Sometimes they're machine learning questions. Machine learning just being a relatively new subdiscipline in computing science as well. All of that kind of goes together to make data science newer. So the actual topics of the course that we are actually going to be talking about, I guess this is where we are now. I'll have a little bit more to say today on this. How do you just work with data in Python specifically? We'll talk about these tools. And then how do you do data science? And the term data science pipeline is one I will use a lot. That is basically like, well, I got to get the data. Well, I've got to figure out what I'm doing. I've got to get the data, deal with the data, and then start trying to get answers out of it. And there's basically two categories of technique that we're going to use to try to get answers out of data, and it's inferential stats and machine learning. Of course, you have a stats prerequisite. I'm going to assume that you know something about inferential stats. I'm also, as a realist, I'm aware that somehow the stats prerequisite does not generally result in a huge amount of stats knowledge, which is fascinating. Anyway, so how do you do this? How do you actually get useful answers out of data? Towards the end of the course, we'll talk about some big data tools, which is basically, if I have so much data that the other stuff we're talking about this semester isn't working, what can I turn to? Well, it's the big data tools. And then, well, once you have those answers, how do you communicate those to someone? Or maybe this is a more useful outline. These slide decks are arranged by like topic. You know, it's not like each one takes an hour or something like that. They're as long as they need to be. I guess I will point out here, like, you presumably have found this video by clicking on the link right here, because I'll fill it in later. I'll keep the sort of schedule of lectures, like what I've done, partially for myself, just so I know where to start next week, and then the video links so you can find them. These Friday lectures mostly won't exist. I guess I can fill in the quizzes there. Anyway, how are we doing? Feeling good? So we're about half an hour in. That feels about right. I will, like I said, I will stop in about 20 minutes at the end of the first hour of today's lecture. We'll take a 10-minute break, then the next video will start. Okay, so this is, yeah, this is really the question of the course. It's what do I do with data, I guess, to get answers out of it? And well, the answer is, of course, it depends. The answer to every good question is it depends. But there is at least a I don't know, category of techniques here, or there's a common like workflow. There's a couple different like, if you Google data analysis pipeline, you'll get people's various list of steps here. I have been pretty reductionist. Oh, this one has disappeared. Oh well. And this one is somewhere. Yeah. Sure. This is not a magic list. It's not like what is step 4 in the data analysis pipeline is a question that I think is interesting. But this is often how things go. I'm actually going to leave that slide open. I'm going to keep that and then move along over here. I think this is totally reasonable that people think data science is all about step 4. It's about doing data analysis, and it's really not. Data cleaning, like just, again, going from the data that you have to the data you need sort of steps is often a huge amount of work. Like I've talked to students who did co-op in data sciencey things, and it's like, yeah, they come back and they're like, yeah, you were right. Yeah, that's right. Because it's not like, well, and frankly, this is one where I am doing a bit of a disservice, right? Like, when exercise 2 comes up or whatever, I'm going to hand you data to solve this problem because I want you to deal with the technique of exercise 2. But that's just not it. Like, I have prepared that data or I've chosen a question that fits the data. Usually you don't have that luxury. Now, let's have a look at the pipeline. And I'm starting here. This figuring out the question business is all down here. Like, what question is really being asked and who cares, and what kind of answer is a real answer versus a useless half answer. All of that stuff depends on the question, and the question depends on who cares and what would be a useful answer to the question that isn't quite the one that was asked. This example, because I've literally had this kind of question, there's roughly speaking, a data warehouse for SFU academic data that some people have access to, and they get questions like this. The advisors might ask, like, oh, how many students have a GPA below 2.4? And what question they're really asking, and I know what question they're really asking, but it's not actually what they asked. Because, and this is really annoying, right? Somebody asks you a question and you ask them 17 follow-ups. They thought they were done answering or asking the question here, but no, we're not done yet. Who is our students in this story? I bet if you ask, like, and I've gone through conversations like this where they say, oh, compute majors. Is it though? Is it people in the data science program? Is it people in a computing minor or the joint linguistics or whatever the heck other majors? Or does it include intended majors? And of course, there's nothing in any database at SFU that encodes your hopes and dreams. Intended majors is not something we can query for, but maybe we can query for students who take a lot of computing courses and figure those are either in a compute program or would like to be, or probably more likely it's just, the question is, how many students are going to be asking advising questions about their low GPA? This one, I literally have something in my inbox right now where I'm going to have to go back and say, what do you mean? What do you mean student? Because there's no rule that says you have to be taking courses right now. You can just take the summer off. Maybe you have some friends that are, and you go traveling, or you do your work or whatever. Like, that's all legal. We allow SFU students to do that. So if you're not taking students this semester, are you still an SFU student? Yeah. After 3 semesters, are you still an SFU student? I don't know. There's probably some registrar, I'm sure, has some rule about this. I don't know what it is off the top of my head. Maybe there's some flag on students that they go from active to withdrawn. I don't know. This is like legitimately, I'm not sure I know the answer to this question. There's many things called GPA. I think this is probably like normal cumulative GPA, but well, depends who's asking. I don't know. And again, it's annoying to have to go through this, and this is a problem domain where I think we all kind of know what's going on. We know what SFU GPAs are, and we know there's a computing science continuation GPA and all this stuff, right? A lot of domain knowledge goes into understanding what this question is actually about. Probably more questions about what you're talking about than there are SQL queries to answer it. So this is, like I said, I am doing a disservice to this sort of aspect of the data science pipeline because, well, one, I'm not going to ask you to like, spend half of next week learning about, this weird, I don't know, whatever problem domain or whatever data set, because that's a waste of time. I'm going to stick to topics that you kind of understand. And I'm going to be handing you problems that are pretty well formed because that's just how assignments work. Now, the project is much less well formed. You do have to do this figuring out the question for the project. It's frankly the big part of the project is just figure out what you're doing. But once you have a problem, you have a sort of well-formed question that you think you can answer, then there's a question of, well, do I have the data to answer it? And the answer is not always yes. Maybe the data's out there, and like certainly, again, I've talked to students who are on co-op or early in the job market, where it was like, well, my boss wanted to know this, and we definitely have that data, but it's some other department's data. So I had to go to the manager in the other department and ask them, and then they had to ask their manager, and it just takes, there's just bureaucracy because organizations are large and that happens. Sometimes the data doesn't exist and you have to get it. If you are imagining a project in this category, of course, you'd better figure this out really soon and make sure the data is collectible. Can you get it or whatever? Or sometimes that question is impossible. And again, this is things like, are you an intended major in computing science? I cannot answer that question. That is an impossible question to answer, at least from a database query. I guess I could ask you, we could do a survey. But what I could do, again, like I said, is we could query like, who has taken 4 CMPT courses in the last 3 semesters, and say, well, this is probably somebody that the advising staff cares about and might think of as computer science-y or something. That's a different question, but it might be good enough and it might be the best you can do. Just the data existing in some abstract form is, of course, not the same as having it in a data structure in your code. It might come in nice in a file, a nice file or an ugly file. You might have to like query some API to get it, and make 10,000 API calls so you can get 10,000 JSON files and then try to make sense of it. Maybe there's a database query. Maybe there's I don't know, the temperature sensors or whatever. Come back to a little bit of that today. And then there's a part that, again, you're not, unless you've done it, I feel like you don't know how weird this gets. Just, hey, there is some data. Every little while, I will give a data set for an assignment in this course or somewhere else, and there'll just be extra columns in the CSV file or whatever. And I get students who come up to me and say, "Oh, what do I do with this field?" I say, well, nothing. Sometimes this data set has this, and you don't need it this week. It's fine. I have seen data sets that have a column for like mass, and the number isn't in the same unit all the time. There's another column for what unit it is, which is super annoying, but I've seen it. Sometimes you have string identifiers, and like, do all 3 of these strings mean the same thing? Well, I mean, this could be, I don't know, Microsoft services for Unix or whatever. This could be the guy, the explorer or whatever. But, if the column heading is what university, or the question is, what university do you go to? I don't know. Is there something called like San Francisco or San Fernando University or something? Maybe. This is just real. Like if you ask a human to type a string, who knows? This, you would think this would be weird, but I've seen exactly this happen. It was some kind of science machine, some kind of like thing that reads the plates or whatever, and it generates a CSV file on your USB stick or something. And depending how it's set up, it might add this column or it might not. Or if it detects something, it adds that column. But if nothing was ever detected, it leaves a column out, and it's really annoying. But it's real, or just not the data you wanted. It's in some weird format, or the data exists and you love it, but it's wrong. And again, not all data is perfect. Just the person who was supposed to write that number down was sick that day. The sensor failed, all of these like totally normal things, or the logging system failed that day or something. Maybe the data looks weird because it's weird. Maybe the data looks weird because it was typed wrong. Which is it? I don't know yet. We'll talk a little bit more about noise, just sensor noise. All these things happen. All these are things you have to deal with in real data sets. Like that New York Times article, it was linked a few slides back, that is now actually quite old, but it's still true that cleaning the data can be a huge fraction of a data science task. So we will talk about a few things. We'll talk about some common techniques and some things that you're sort of maybe more likely to see, but sometimes it's just a lot of work, and a lot of like those like judgment calls that turn into lines of code, right? Like I want to keep the things that have I don't know, daily readings for all 365 days. Well, but maybe if 1 or 2 days is missing, I'm okay with that. What if I have a thing where there's only 360 recordings per year? Am I okay with that? Well, I have to make a judgment call as a data scientist, and that's going to turn into code. This is one of the reasons, by the way, that like, I'm not super worried about AI taking all the data science jobs, because an AI can write that line of code, but the judgment call of what fraction or what you do with missing values or what each outlier really means, if you lean on an AI for that, you deserve to be replaced by an AI. That's dumb. You need to make that judgment call. Then actually analyzing the data. Again, the thing that you think of as data science, it is part of it, but only part. What you should remember here is that there's some answer you care about. Again, it's a little bit unfair on the weekly exercises because I'm giving you a very clear destination to approach, because it's an assignment. But what answer do you want, and can the data get that answer, either the yes or no version of it? Depends. So this more involved Venn diagram that is from a KDD is knowledge something in discovery. Anyway, it's from a KDD conference, which is why they're in the center. And again, is this the most, it's more than 10 years old. Is this the perfect way to express the sorts of things you can do then call data analysis? Well, not really. It's not all of them, certainly. But yeah, statistics, we will talk about machine learning. We will talk about data mining. We won't, but we have a course in that for something. I'm not sure neurocomputing, it's a thing. I'm not sure it deserves to be in the, the top 6, but sure. Like I said, we've got 2 sort of main categories of data analysis tools. we'll come back there. And of course, it's not everything. That just is what it is. Okay, so wrapping up this data analysis pipeline, I have written it as interpret and present results. This is, once again, the sort of thing that computer science students don't think about often, or often don't put the value on that it deserves. But you can do the world's most clever data analysis, and it means nothing if nobody knows about it or understands what you did or understands what it means. This is super important. I mean, one of the things I said back here in the intro, actually, when I was talking about the project, what did I say? Report. Anyway, somewhere in here I said that you read a report, and I said that's the primary sort of output of the project, because yeah, that's like, okay, yay, you wrote some code that turned this data into that data. Who cares? What's it for? What did you actually find? What question did you answer? Is your answer, complete or partial or whatever? That again there's a lot of human judgment calls in writing that. If you have an AI write it for you, prepared for 1, an academic dishonesty case, and 2, a crap project mark, because the bland output of every large language model is going to be a very bland project that's not interesting. This interpretation and explanation, well, if you can't do that, nobody's going to pay you to be a data scientist. So this is, and I guess I will also apologize on this one for not spending enough time on it. Again, it's a focus of the project. It's a focus of like the very last exercise in the course. But, I'd like to think the technical writing course will address some of this. I know it doesn't always, or not perfectly. We do have a data visualization course, whatever Sheila Carpendale teaches, that starts with a 4 or a 7 or something. But we'll talk a little bit. So this data analysis pipeline, which again, this sort of abstract concept of data analysis pipeline, often turns into code. Maybe it turns into a single program and you just like press run and the answer falls out the other end. Sometimes there's steps there that take a long time or require network or, rate limited, or, it just takes 10 minutes to do this step. And you don't want to worry about the 7th step, or you don't want to be writing step 7 when step 6 takes 10 minutes to run and you have to wait every single time. You want to break that up. Maybe you want to debug by seeing what happens halfway through. So I find myself very often creating separate programs. That can be weird if you don't document it and you don't remember what all the parts are. It means that, getting your 1 true answer requires running 6 programs instead of 1. But it means that you don't have to wait for the data scraping to happen when you're training your machine learning model. This is already run, it's produced its output files, and those are being read by this step. And it's writing output that's being read here, it's being read here. Or I actually literally was writing this code today. And I ended up, I found myself writing this basically with the phase coming from the command line. I'm going to do step 1 now, do the thing, write out the data that ends step 1. And then step 2 is read that data, do stuff with it, and write that data. And, maybe switch tools, or you can do whatever in between. Again, I wrote code very much like this today, because it could be that the thing that happens here in step 2 takes 10 minutes, 15 minutes. I don't want to, mistype a variable name here and have to wait 10 minutes to find out. Okay, this is a good spot for a break, so I'm going to take one. So what's going to happen here is this video is going to end, and then there'll be a video link here. Go to this video. I'll be there in about 10 minutes. See you there.